Okay, welcome back again in Ram circle class. Today we are going to discuss about the cells and their combinations. The cells have been done in the first part. The second part is what? Combination of cells. And the very first of that case is cell connected in series combination. Okay, so let's get started. We have a series combination of cell and the cells are connected as I'm doing. Please see carefully. This is positive terminal, this is negative, this is positive, negative, and so on. For simplicity, for avoiding the complex calculation, I am taking only two cells. Okay. Now consider its EMF is E1 and that of E2 is this. These are 2 points A, B and C. Its internal resistance is R1 and that of this is R2. Okay. What remains constant or same? I mean to ask potential or current in series combination of resistance. Obviously it is current. So in series combination of cells we assume that, or it is fact, what? The current remains constant. Now current remains same means if current I is flowing through this cell, then I will be the same current through this cell as well, and this is an external resistance capital R. Okay, so we know that the terminal potential of the cell is given by EMF of the cell minus the current multiplied by its internal resistance. Okay, now see very importantly and very carefully the potential between A and C, that is the point connected or connecting the two terminals of the first cell. So V A B equals to VA minus V of B will be equal to EMF of the cell minus the current and R1 according to this relation, and this is what? Terminal potential, EMF of the cell, and so on. So VAB equals to what? The potential difference between the two ends A and B. Similarly, potential difference between B and C, the V at BC is equal to V of B minus V of C, and that is equal to second EMF, as the current is same, so I will not write I1, I2, rather it is I, and that is R2. Clear? Now this is a cell combination, and finally the A and C are connected to this current or this resistance. So potential difference between A and C is equal to how much? That is V AC equals to VA minus VC. Now this relation can be written as VA minus VB plus VB minus VC. Okay, I have simply subtracted and added what? VB. Now VA minus VB is equal to E1 minus IR1. So this is E1 minus IR1 plus, and this is equal to VB minus VC. Mind it, VB minus VC equals to EMF IR2, and that is what? VAC. Now what is VAC? Can you define this? VAC is very interesting. This is the terminal potential of the cell combination. Cell combination means, consider this is a single cell, right? And these are the end points through which the resistance is connected, or we can say VAC is the potential across this resistance R. So may I write this VAC equals to simply V or V is equals to, this can be written as only terminal potential of this cell combination. So V equals to what? This plus this, that is I is taken out, R1 plus R2. Okay, that is equation number first. Simple and clear. Now what if this combination is replaced by a single cell? That is what we know in physics is called equivalent cell. If this combination of cell is removed by a single cell which does the same job as was being done by this combination. So if this arrangement, this is replaced by a single equivalent cell of EMF, what? E equivalent, and internal resistance R equivalent. Mind this. This is what? This will be what? I am replacing this and will be adding a third one. So the third one will have equivalent EMF equal to this, and its internal resistance will be equal to this. Then what will be the equation in that format? Because again the job is same, so the terminal potential between A and C will be same. So we must write either VAC or simply V. So things will be same. So V is equal to E equivalent minus I R equivalent. That is okay. Equation number 2. Now as the terminal potential of the cell combination, or you can say the terminal potential or potential difference across the R is same, because either if use this combination or single cell, that does not matter, the potential difference will be same. So the left hand side of these two equations must be same. So we get from first and second, that is now from first and second, what we get? E equivalent is equals to this. That is importantly what? E equivalent is equal to E1 plus E2. Okay, getting this? And the R equivalent is equals to what? R1 plus R2. Very simple. So here we reach our final conclusion for two cell combination. That is, when the cells are connected in series, the equivalent EMF of the combination becomes equal to the sum of their individual EMF. This is what? The sum of the individual EMF of the cells, and that is the internal resistance of the combination is equal to what? The sum of their internal or individual resistances. Okay, now this is, again have a look, this is the relation. So VAB has been written as VA minus VB, and that is equal to, for this cell E1 minus IR1, because I or current will be same in the both the cell combination. So if this arrangement extends to a large number of cells, then what happens? This simply get added up to a same number of terms. For the purpose, if n number of cells are connected rather than this, so we extend this line by adding few more number of cells, and this goes up to n number of cells. Then the equivalent EMF becomes is equals to E1, E2, E3 up to En. Okay, and the effective internal resistance of the combination is R equivalent is equal to R1, R2, R3 up to Rn. So what will be the current in the circuit? For current, the current in the circuit is equals to E equivalent over total resistance according to Ohm's law. Total resistance is how much? There is R equivalent. That's it. Very, very simple. Okay, this is clear. This is clear. So this will be obviously clear. So this is the cell combination of different EMFs have been added in series cell combination. Now we are simply arising a simple question. What happens if one cell is added by mistake in a wrong way? There is, mind this is plus minus, plus minus, plus minus, plus minus and so on. But if I by mistake add this cell in this way, the minus plate has been put earlier and its EMF was E2, that of E1, E3 and E4, so on. In that case, what will be the equivalent EMF? In that case, the equivalent EMF of the cell will be reduced by the EMF of the cell has been added wrongly. So it has been added wrongly. So the equivalent EMF is in that case E1 minus E2, E3, E4 and so on. Okay, and R equivalent remains same because the resistance either you add this way or that way, nothing happens. So R1, R2, R3 and so on. Fine. One special case, if all the cells are identical, that is E1 equals to E2 equals to E3 and En all are having value of E, and R1 equals to equal to R3, R, and they all are equals to R. Then the equivalent EMF becomes equals to how much? E plus E plus E up to E, and how many times? That is n times, then it becomes n multiplied by EMF of a cell. So that is E equivalent equals to this, and R equivalent equal to, and equivalent resistance, internal resistance, equivalent internal resistance is equals to N times R. Fine. This is not doubtful case, so be clear about that. Now let's discuss Okay, what is the need of series combination and in which case we should apply series combination and not parallel combination. So for that, if the cells are identical, I am taking this case only, not different. If the cells are identical, then in what way should I connect them? In what way and when should I connect series combination? Let's discuss that. Current I equals to how much? Total EMF over total current circuit resistance of the circuit, that is NE over R plus NR. This is the value of current in this circuit. Now if NR is much smaller than the external resistance, mind this, the total equivalent internal resistance of the cell combination is much less than that of the external resistance, then what happens? Then the current becomes or we must say NE over R, that is N times due to a single cell. That is, if the internal resistance of this cell combination is very small, very less, then what? The external resistance of the circuit, then we must connect them in what? Series sequence. Or this sequence is helpful or going to be worthful only and if the internal resistance of the cell combination is much less than the external resistance. Otherwise this combination is fruitless. So that is a bit conceptual because the board raises questions conceptually from this segment only. Whatever you have done, that is necessary and mandatory as well. So this is forming, or this forms 1 mark question. So please especially have a focus on this. Now let's discuss one more case. If this is opposite, that is reversed, what happens? Case number 2, if NR is much larger than capital R, means the internal resistance of the cell combination is much larger than the external resistance. Then what will be the value of current? N EMF over this term becomes negligible, as in this case this term became negligible. So in this case capital R becomes negligible. So R is approximately equals to 0. So here we get, and it is equals to I EMF over R. That is, current will be same due to a single cell alone. It means if external resistance is much less than the internal resistance of the cell combination, then the current given by this combination will be exactly equal to the current given by a single cell. Then why should I go for this large number of cells? Better I use how many cells? 1 cell. So if this condition is holding, then we must take only 1 cell, not this series combination will be fruitful for us. Okay, so most of the things have been covered in this topic. In the next video we shall discuss about the parallel combination of cell. Till then, bye.